Hello everyone. So this is the fourth lecture in the series of Formula Student. I'm Abhishek Jain, the founder director of ARC Global. ARC Global has been working in the field of student motorsports for the last 8 years. We provide a complete set of solutions for the student teams which participate in any kind of student motorsports event. So be it the go-karting event, ATV event, Supra Formula Student event, e-bike event, solar event, e-cycle event, or any kind of motorsports event. ARC Global provides the complete training solutions as well as the complete manufacturing solutions to the student teams. So if you are the one planning to participate in any such kind of event, feel free to reach out to us for all your motorsports needs. If you are planning to form a team and you want to just begin up with a team in your campus, you can contact us for a complimentary lecture in your campus, making you people understand on how you people can target the student motorsports in India or internationally. Let's move forward. So today we will be discussing about transmission system. In the last three lectures, we have discussed about the chassis frame, steering system, and suspension system. My dear friends, please make sure that in this particular series, we are just discussing about the fundamentals that you people need to have while designing your vehicle. I'm just trying to build an interpretive understanding on how to start with, where to start with, what is needed to be done at first, what all parameters are needed to be considered. Okay, so please make sure this is not a complete solution, but at least it will give you a very good head start when you start designing your vehicle, when you start working on your vehicle. Today, we will be discussing about the transmission system. So I will be going up into very basics, the understanding that you people need to have while designing your vehicle, on how you will be arranging the complete transmission system of your vehicle, what all thoughts that you need to have in your mind while designing it, and how all together the transmission system works in your vehicle. I want you people to stay with me in the next 1 hour to dwell deeper into this particular topic. If you people find out any question associated with the discussion that we will be making today in this particular session, you can drop down a message to me on this particular number. 8800219630. I'm available on WhatsApp with this particular number. Drop me a text on WhatsApp. I will be taking up your query in person. Okay, let's move forward now. Transmission system. Hmm. Now, when you look up into any Formula Sprint team or when you look up into any student motorsports team, you will find that when we talk about transmission system, people have got the powertrain system separately in their team. People have got the engine team separately in their team, or they have got the tires and wheel assembly team separately. If I combine each of these things together, I can say transmission system. Anything that is responsible to transmit the power produced from the source of power to your tires is regarded as the transmission system, which also includes the source of power as well as the tires. Okay, so I'm not just talking about the system that is responsible to transmit the power from source, that is in your case, it is the IC engine, to the reactional surfaces that are your tires. So I'm not just talking about this particular system altogether. Not just this, I'm talking about this complete system in here. How will you determine the size of the tires that are needed to be used in your vehicle? How will you select the engine? We will be discussing about these things now. Okay, so there is no separation of powertrain components, there is no separation of source of power and tires. I've combined everything in there. Please remember this one thing, at the end of the day, you will find out transmission system is the most important system in your vehicle. And what I found out usually when we talk about the transmission system, we think that it will work on some absolute measurements and we forget to work with a geometrical approach of designing or developing the transmission system of the vehicle. My dear friends, please make sure that when you're going to design or develop a vehicle, everything in your vehicle should have to be started up from the kinematic approach of design. Kinematic approach. Please remember this one thing, my dear friends. Okay? Everything stands with the kinematic approach. What do we mean by the kinematic approach? And moreover, what do we actually mean by transmission system? So in here, I will be saying any system that is responsible to make your vehicle move forward is regarded as the transmission system. But it is way more than that. It's not just about moving forward. It's also about maneuvering it. You assimilate it to move forward, right? You assimilate it or you pedal it to get a certain speed, to get a certain acceleration, to get a certain torque, to get a certain torque, sorry, power, and that is more important for us. How will you make this entire maneuverable movement system in your vehicle? That is very important for each one of us. And for that, I would recommend you people please develop the free body diagram, please develop the kinematic model for your vehicle before moving on to the kinematic model. Now, whenever we talk about the transmission system, let's begin it up from the tires. Okay, I'm going to have a mix of approach. First, I will be talking about the tires, then I will be moving up with the engine, and then I will be moving up everything between the engine and the tire. Okay, so let's just talk about the tires at first. Please remember this one thing, your vehicle's complete behavior, response, reaction, everything in your vehicle depends on how your tires are going to react with the tires, with the road. How tires react with the ground. Everything depends on that, my dear friends. Okay, now see, this is my road. This is my tire. Okay, the relationship between this tire and the road is of friction. The upper surface of my tire is generally made up of rubber, natural rubber, synthetic rubber, whatever it is. So now, why do we use rubbers? This is the road, right? The charcoal road, the cemented road. You can have different kind of roads in here, the ground surface. Now, when you look up into this particular surface, you all know this thing, no surface in the world is 100% frictionless. So when you look up into this particular surface, you will find that there are certain surface aberrations, surface irregularities. Surface irregularities. Surface is not exactly plain, there are surface irregularities. If the surface is very shiny, very finished, some special purpose made road, when you look up into with the microscope, you will find out, when you look up with glasses, magnifying glass, you will find out there are certain aberrations, there are certain irregularities in the road. Now, when the tire is made of rubber, you will find out, my dear friends, these abrasions are generally filled up by my rubber. So, when I'm going to put a certain load, my tire rubber is going to be compressed, and when it is compressed, it will expand. When it will expand, what will it do? It will fill inside this particular gap. When it will fill inside this particular gap. Now, just imagine this thing. There are two surfaces that are absolutely frictionless. Absolutely frictionless, completely shiny. They're very hard. There is nothing where you can say there is irregularity or asymmetry or asymmetry in the road. Now, when I will be taking up this particular tire, which is made up of, say, for example, graphite, or when I'm having this particular road made up of graphite having no friction between them, and I place them together, you will find that the contact surface between these two bodies is very less, is very minimal, and is absolutely equal to the watchable area, what you can see. Okay, what you can simply say, this is the area where it is in contact. So the contact area which you can see in here, visualize, will become the contact patch. Will become the contact patch. But if there is a bit of friction between the road and the tire, you will find out the visible contact area is going to be lesser in comparison to the actual contact area. Why? Because inside this particular region, you can see your rubber is getting entrapped. Okay, it's getting entrapped. It is going to lock inside, right? Lock inside. See, Hmm. Deeps and valleys, deep and valley. This is the valley, this is the deep. So this is the road and this is the tire. Making it a microscopic view diagram. Now you can see this is locking, right? This is locking. This is locking itself. So if I apply a certain load to move it forward, then actually you will be saying the weight of my vehicle is 100 kg. You just need to apply the X value of load to move it forward. But because of this friction, this load could increase. This load could increase because of this particular locking in the deeps and valleys, depths and valleys. And this particular thing is very important for us because these deeps and valleys make the grounds of stability for our vehicle. Stability for our vehicle. It means if you're working at a high speed, if you're working at a low speed, in whatsoever condition it is, it gives you the advantage of controlling its motion. It gives you the advantage of maneuvering its motion. The force that acts between the tires rubber and the road is regarded as the adhesive force. Okay, please remember this one thing. Adhesive force is the force that acts between two different kind of material. There is a rubber, there is a road. Two different kind of material. So there is the adhesive force that is acting between them. But if I just talk about the rubber, the tire, different layers, there is a cohesive force that is acting inside. Cohesive force. When I apply a certain load, this rubber also compresses or this rubber also expands. This rubber also expands. This rubber also expands because of the temperature, because of the increase in temperature. As the temperature increase, expansion of the rubber also increase. And this particular phenomena, my dear friends, is known as hysteresis. Hysteresis. Okay, there is also a phenomenon of hydroforming. What do I mean by that? You see, this is the road, this is the tire. Hmm. Now, when there is a water, say it is raining, and it is raining. So you can see, you must have noticed that whenever it rains, you move your vehicle forward, water comes down from the rear portion of the tire in certain form, right? Inside it sprinkles out. It sprinkles out. In actual, it should have to just move out in here, but it moves out. If it should have to move out, it should have to have this complete radial pattern. But there you can see the spatter of the water, the split of the water droplets. And this happens because the water tries to entrap inside this particular deeps and valleys. In these deeps and valleys, the water is trying to entrap. Now, your rubber is trying to entrap inside it, but because of this water, it is not getting entrapped. If it is not getting inside it, it means the locking between the tire and the road is less. It means the grip is less. If the grip is less, it means the stability is less. Why? The stability, whenever we talk about the stability, it means are you able to control it? Are you able to maneuver it? No, you are not able to maneuver it. If the maneuver ability is less, it means the stability of the vehicle is also less. So accordingly, you change different, you use different patterns of the tires. Use different patterns of the tires to make sure that in any condition, your tire will always have the maximum contact patch with the ground. Maximum contact patch with ground. Now, whenever I talk about the contact patch, I'm referring to both the lateral contact patch and the longitudinal contact patch. Okay, I'm referring to both of them. So, the contact patch should have to be as high as possible. Okay, in the plane of road, that is the lateral and longitudinal axis. Okay, now having said this thing, when you're going to decide what tire is needed to be used in my vehicle, how will you make up the complete story? Let's just talk about that. And before we talk about that, I want you people to have this understanding that ARC Global provides all kind of training programs. So if you're a student team planning to participate in a go-karting event, ATV event, Supra event, or any other kind of event, we have got 7 days exclusive programs for an entire team. Okay, 7 days exclusive programs at very minimal cost, where 30 members from your team and at max 30 members from your team can attend this particular program. 2 hours of class each day, 1 hour of assignment each day, and everything that is required to design your vehicle is going to be covered up in these 7 days. For extensive understanding, we put 15 days program as well, where we cover the CAD and theory approaches as well, and the complete calculation which is needed to be targeted as it is to design our vehicle. Why do we have these programs? I found it in my experience that no particular video, no particular book, no particular research paper can give you the exact understanding on how this vehicle is made to be designed. And moreover, the teams which have got the hierarchical order set up in the vehicle and have been participating for quite a long time, they're very weak at basics because they always improve the current edition of the vehicle, the last edition of the vehicle. But the teams which are designing the vehicle from the start, they've got a very good understanding of the fundamentals. But at the same time, they are constraints with the current trends. They are constraints with the risk assessment that is needed to be performed while designing or developing this particular vehicle. Okay, so my dear friends, you can join up our 7 days programs or 15 days programs at your convenience of home and get a complete understanding of how to design your particular packaging of it. Over that, we have got the individual programs as well. 30 days internship cum training programs on automobile engineering, on EV design, on CAD, and on CAE. Each of these programs comes up at a very minimal cost of 3,500 rupees only, having 4 different modules. Say, for example, if you plan to join our automobile engineering internship and training program, in the first week, we will be discussing about the fundamental of automobile. It means every literal part that is required to design or develop your vehicle is going to be covered up in this particular week. Your superchargers, your turbochargers, your chassis frame structure types, your braking types, everything is going to be covered up. Say, for example, if you go to the marketplace, you will have the complete understanding on what all parts are needed to be taken up to integrate and build this particular vehicle. You would be able to differentiate between different two running vehicles onto the road. In the second vehicle, we will be discussing about the integrated approach. If you need to integrate all the subsystems together, what all rules, what all laws are needed to be followed. In the third week, we will be discussing about the implementative process, that is the CAD. Whatever you have studied up till here, you will be able to give it a shape. And fourth week, we will be studying about the CAE, how you will simulate whatever you have designed in third week. You will get 3 certificates: certificate of training, certificate of internship, as well as a certificate of completion of project, which is applicable if you will be able to complete the project on time or not. So please think of joining each of these batches, whatever the batch that you want to join. Just join. Every Monday we start a new batch at 8 p.m. So feel free to join our batches. Thank you so much. Let's move forward. You can also think of following us on Instagram. We are available on Instagram with the name of ARC Global. Our username is _ARC Global. We are available on Instagram with _ARC Global. Follow us there. You will find out all the latest updates of our coming sessions and whatever we people are doing at our workshop at our place. Moreover, we are planning to come up with the informative reels on Instagram as well. So please follow us on Instagram. Let's move forward. Now the question comes up: how will you select the tire size, tire shape? Now, if you want to use the dry tire, if you want to use the wet tire, that entirely depends on the use case. But what tire size is required? To understand the tire size, we need to remember what are the different parameters of the transmission system. First is the power. Second is the torque. Now, if I further derive these two terms, you will get acceleration, you will get velocity, you will get gradability, you will get towing capacity, and you will get payload capacity. If I further derive these two terms, these are the 5 parameters that you find out in your transmission system, in your powertrain, in your transmission, in your deciding how what engine is needed to be used, what tire size is needed to be used. Okay, what do we actually mean by power? What do we actually mean by torque? Let's just try to understand this thing. Now we know this thing that your vehicle needed to be moved forward. So this is my tire. Okay, so if I push it, how much force do I need to apply to move it forward? The first question comes up in here. Okay, or if I say I've got a power source, my engine, this engine is not pushing, this engine is providing the rotation, right? It's rotating, right? It is providing rotation. So this force, whenever anything is rotating, this force will be converted into torque. I will be talking about the torque now. So how much torque is required to be provided to my tire so that I would be able to take 100 kg of load? If I say so, please remember this one thing: the very fundamental unit of life, the very fundamental unit of any system is energy. Now, energy itself is a container. You cannot do anything. You have got a bucket full of grains, right? But you need to get the food out of it. So, to derive it, we use the power. Okay? To derive it, we use the power. Power, what do you mean by it? Secretion of energy. When I exhaust the energy, the rate of conversion of energy from one form to other form is regarded as the power. Rate of conversion of energy. Rate of conversion of energy. So when I say rate of conversion of energy, energy is being converted from chemical energy form to kinetic energy form. In the case of engine, right? In the case of engine, this is what is happening. I've got a fuel. I've got a fuel which is having a certain calorific value. And I am converting this calorific value, this energy, into the kinetic energy. And when I do so, rate of conversion it is changing. When it is changing, when I talk about the kinetic energy, it means motion is happening. Motion is happening. So when the motion is happening, my dear friends, you will find out it is having a certain rate. And that rate is regarded as the velocity. That rate is regarded as the velocity. I am sitting here, I reach this particular position. I was standing here, stationary. I reached this particular position. How much power have I consumed? So first, I change this particular position. So, say for example, I must be having certain velocity, and it took me 3 seconds. Now here I started up, I will be having certain velocity. This velocity will increase or this velocity will reduce in the way, or it will remain constant. It means I will be having certain acceleration as well. From 0 to 1, from 0 to 0.1, that infinitesimally small value of acceleration is also needed to be considered. My mass will, this particular acceleration is the force, and the velocity with which I move forward, this product gives me the power. In our case, I will be saying this force is torque, and this velocity is RPM, rotational velocity. Is the rotational velocity omega. Okay, so let's just try to understand about the very basics, how this power is being converted. Then we will be moving a bit of time. Our engine is the power source, IC engine. Okay, it is the power source. Now, how does this work? It converts the chemical energy into kinetic energy. What kinetic energy do we have? At the end, we will be having the shaft, the output shaft that is rotating. If it is rotating, it means it will be having the rotational kinetic energy. This particular shaft will be having the rotational kinetic energy. Please remember this one particular point, my dear friends. Okay, so now my engine, everything in this world is made up of energy. It is made up of bundles of energy. So I will be using a certain fuel. The only thing is to extract this energy, different instrumentations are required. To extract the energy, the kinetic energy, sorry, the chemical energy of the fuel, we will be using the IC engine. We will be using certain conditions inside the IC engine to extract this particular energy. So, for example, I will be using a petrol. If I say 1 kg of petrol is equivalent to 45,000 kilojoule of energy. I'm just saying this thing, I'm not sure if it is 1 liter or 1 kg, check it. If I say 1 kg of petrol is responsible to 45,000 kilojoule of energy. I know this thing, density of the fuel is somewhat around 700 or 800, but as of now, I will be saying if the density of the petrol is 1000 only, then 1 kg is equivalent to 1 liter. Okay, 1 gram is equivalent to 1 milliliter. Just for the ease of calculation, I am doing this thing. So if I say, if I am going to use 1 liter of petrol, I will be getting 45,000 kilojoule of energy. 1 liter of petrol is having this particular set of energy. I need to extract this energy. If, say for example, you have got a vehicle in your home. Say for example, if you say I use Alto, and you say the average of the Alto is 20 kilometers per liter. If I move my vehicle at a speed of 60 kmph, I got this thing. I got this thing. If you know 60 kmph, you can also say what RPM of the tire because you know the tire size. If you know the tire size, you know the gearbox that you are using, you can also say what engine RPM of the engine. You can also get up to this particular statement. You can find out this particular thing. Now, at a speed of 60 kmph, the maximum average that I will be finding out in my vehicle is 20 km per liter. It means I will be using 1 liter of fuel to move 20 kilometers at 60 kmph. Okay, where I will be completely exhausting 45,000 kilojoule of energy. 45,000 kilojoule of energy. So can I also say to move my vehicle for 1 kilometer, how much energy will I be consuming? I will be consuming 20 liter. Okay, it is kilojoule per liter, it is 20 liter. 1 kilometer, this is the energy that I will be using. Okay, my dear friends, please remember this one thing. I am moving my vehicle at a speed of 60 km. So if I write down, it is being consumed in 1 hour, 20 liter, for instance, 20 kilometer per hour. I can also calculate the power, but this is not my concern as of now. This is not my concern as of now. Okay, so I will be saying to move my vehicle 1 kilometer, I will be consuming 45,000 by 20, 4,500, 2250 kilojoule of energy. Okay, in how much time? In how much time? If my vehicle speed is 20 km per hour, to move 1 hour, 1 kilometer, how much time will I take? How much time will I take? 20 divided by 60 hours. Okay, 20 divided by 60 hours. So I can say how much power is being consumed. Power to move 1 kilometer, 2250 kilojoule divided by power is being consumed 20 divided by 60. Am I right here? Just check the time. Okay, just check the time. If the speed is 60 kmph, to move 1 kilometer, how much time will I take? Sorry, 20 kmph. To move 1 kilometer, how much time will I take? So it will be around 20 kilometer per hour. That is, to move 1 kilometer, I will be taking 3 minutes. Or you can say 180 seconds. Okay, simply divided by 180 seconds. Or for the sake of calculation, let me just say 225. So I will be getting 10 kilojoule per second, or I will be saying 10 kilowatt of power. It means to move 1 kilometer, how much power is my vehicle consuming? 10 kilowatt. Is it possible? No. What you will find out generally in your vehicles, to move 1 kilometer, you require 100 watt of power. In the case of Altos, it's about 6 Alto or Eon, some vehicles in that particular category, you will be having 80 watt to 120 watt to move 1 kilometer. In case of SUVs, it's going to be about 150 watt. In case of some heavy vehicles, it's going to be about 200 watt. In case of buses having 50-seater capacity, it will be about 1.2 kilowatt to 1.5 kilowatt to move vehicle by 1 kilometer. This is what you will be finding out. But why I did this thing, my dear friend? I did this thing to make you people understand and actually found out to make the vehicle 10 kilowatt, how much power you are consuming. It's not how much is required, it's how much you are consuming. It's 10 kilowatt to move 1 kilometer. And actually, you will be finding out it's only 100 watt or much lesser than that. So, where does the majority of the power went up? Now, first, to convert the chemical energy into kinetic energy, you will be having the irregular heat energy. So, some of this energy, say for example, 50% of this energy is going to be distributed in that. Got it? Now, you will be having the engine. There are going to be parts that are moving inside it, your piston, your crankshaft, your camshaft, your shaft itself. There are going to be certain losses. Say, for example, 10% of losses. Now, over that, you will be having the complete mechanism. You will be having the clutch, You will be having the gearbox, and you will be having your tires, rims along the complete assembly. 10%, 10%, 10%. See, at the end, how much will you have? Now, again, your engine is going to be used to provide vital function to other systems in your vehicle. Your air conditioner, your other parts, headlights, power steering, power suspension, power braking in your vehicle. So this is where the rest of the power is going to go up. And whatever is going to be left out will be used to move your vehicle forward. So this is how you need to understand the basics. You need to understand how the entire transmission system is needed to be set up, how this entire conversion of energy works at the very first place. Okay, now I have designed the complete system and I found that I am using the engine which is producing 15 Newton meter of torque at, say for example, 5000 RPM, or which is providing 50 kilowatt of power at, say for example, 7000 RPM. Okay, I found out this particular thing. Now, how I calculated it? At the output shaft I calculated it. What do I mean by this thing? I meant by this thing that at this particular shaft center, at a distance of 1 meter, if I put up a load of 50 Newton, then this shaft can rotate this particular system at an RPM of 5000. At an RPM of 5000. When I reduce this, when I increase this way, this RPM will reduce. It's simple. It's simple. That's it. Okay. And what do I mean by this thing? 50 kilowatt at 7000 RPM. Now, as I said, I am going to put up a load of 50 Newton at a distance of 1 kilometer. Sorry, 1 meter. At a distance of 1 meter. Now, at this particular thing, when I do so, my dear friends, when I do so, you will be finding out as I increase or I reduce the length, the RPM will change. The maximum RPM that I will be having is this. The minimum is going to be something else, and that depends on power. So I am moving forward. How much load can I carry is the how much force I can apply, or the torque, if I need to develop the analogy. Okay. Now I can take up 10 kg of load, that is the torque. I can take up zero load and I can move at a speed of 100 meter per second. Sorry, it's way too much. Say for example, 20 kilometer per hour. I can run. But when you increase the load, I increase the load. What happened? This speed reduced to 15 kmph. Okay, this speed that you are finding out here has got a relevance with the power. Has got a relevance with the power. This load that you are carrying here has got a relevance with the torque. So you can say that power is the product of torque and rotational speed. Okay, this is what we will be finding out. We need to figure out how much torque is required to move the vehicle forward. Now this is a vehicle. I do not know what tire size am I using as of now. Now I will be telling you how you need to find out the tire size as well. Okay, so this is the vehicle moving forward. I will say the total weight of the vehicle is 1000 kg. The weight of the front tire is 400 kg. The weight of the rear tire is 600 kg. I am using the engine which is providing power to the rear tire, rear wheel. Now I'm not going to get into the intricacies of rear wheel driven and front wheel driven as of now. I will be taking up now only, but a bit later. Just consider that the total weight of the vehicle is 1000 kg, and I need to move this vehicle at a speed of 60 kmph. So simple as someone asks you, what is the torque required to move this vehicle? You will be saying the force here is 10,000 kg into 9.81 multiplied by this particular speed. This is the power that is required to move it at this particular speed. Move it at this particular speed. Now, as I am moving it forward, my dear friends, to achieve this velocity of 60 kmph, someone took just 5 seconds, someone took 10 seconds, and someone took 30 seconds. This particular thing is force, your acceleration. Your acceleration, so 1000 kg multiplied by acceleration will be torque. This acceleration further multiplied by the velocity is the power. I hope it is clear to you. Okay, this now you need to find. Now, I have made this vehicle. I know in this vehicle I have put the tires. Now these tires are rotating. So I need to find out the power. I need to find out the torque on the basis of rotational torque, rotational force that will need to be developed on my tires. How will I do this thing? Now, to achieve, whenever you need to find out the tire size, everything depends on the tire size here. When you need to find out the tire size, there are two things that you need to remember. The first set of parameters depends on acceleration, torque, payload capacity, and towing capacity. And the second thing here is the velocity. So if my engine is producing 3000 rpm, 3000 rpm, and I need to produce the maximum velocity. Say for example, I need to produce 60 kmph of velocity. I'm using this smaller tire having 15 inches of radius, or I'm using another tire having 20 inches of radius. What is the RPM required to achieve 60 kmph? Just simply calculate it. So there are two tires. I need to achieve a velocity of 60 kmph. Now, what tire size is required? Radius. When I increase the radius, my RPM required will reduce. So 60 kmph here is equal to 2 pi r, that is the radius of the tire, into n, that is the RPM. Okay, divide by 60, make it into kilometer per hour and whatsoever way you want to do it. Okay, now see, RPM required to achieve this velocity depends on radius. Greater the radius, lesser is the RPM required. Lesser the radius, greater is the RPM required. Greater is the RPM required. Please understand this particular principle. So now I got this thing, I got this understanding that if I require the higher RPM, if I need the higher velocity, I need to use the tire having higher size. Now my engine is producing 3000 RPM, and in between I will be having 5:1 gear ratio. That it means I am having 600 RPM available at my tire. At 600 RPM, what is the velocity will I be having? If I use X size of tire, Y size of tire, this is how you need to calculate it. You will be finding out this particular thing. Just to simplify it, I believe that I have just simply complicated this thing. So I will be taking the reattempt just to make you people understand, just to simplify the entire process. How to select the tire size? Tire size selection depends on two parameters. First is the acceleration, payload capacity, towing capacity, and the torque. So for example, it just depends on acceleration. And the second, it depends on the velocity. When you increase the velocity, your acceleration will reduce. Okay, simple. Simple. So first is the torque principle, second is the power principle. With the power, I say you want to increase the velocity. With the torque, I say that you want to emphasize on acceleration. So these are the two parameters on the basis of which the tire size is needed to be calculated. So for example, if I require 100 Newton meter of torque at tire to move my vehicle forward. So this is my vehicle. How I calculated this thing? The total weight acting here is 1000 kg. 1000 kg. The tire size is, say for example, tire size is radius is 20 inches. Sorry, 10 inches. Radius is 10 inches. So the torque required to move it forward, you will be saying mu into 1000 into 9.81 multiplied by the radius of the tire. Now this is the torque required to break it. To break it from ground, to break it from the stationary position and move it forward. Okay, this is the minimum torque required to move it forward, my dear friends. Got this thing. Now, to achieve this particular torque, the torque is 100 Newton meter, engine is producing 20 Newton meter. It means in between engine and tire, you need to use 5:1 of gearbox. 5:1 gear ratio is required between them. Okay, if this particular gear ratio is required between the tire and between the engine, your engine is producing 20 Newton meter at 1000 RPM. Now, when this gear ratio is being implemented, 100 Newton meter you will be able to achieve on the tire, but your RPM will reduce to 200 RPM. The question comes up, is this 200 RPM sufficient to get you the speed of 60 kmph? Now, to achieve the speed of 60 kmph, accordingly you will be using the tire size. Accordingly, you will be using the tire size to achieve this particular velocity. I hope this has given you the clarity how to select the tire size on the basis of velocity, on the basis of required velocity. Now, if you know this thing that I need higher torque at my tire, you have calculated this is the payload that I want, you calculated that this is the towing capacity that I want. If you have calculated this is the gradient that I want, then on the basis of these three factors, you can find out what is the torque required, the maximum torque required. Your engine is producing XYZ torque, you need to convert it, and accordingly you will be selecting the tire size. So the tire size is always a compromise between the velocity and the torque required. Torque required. Okay. So I will be just continuing up with this particular lecture. This is the part 1. The part 2 of almost 15-20 minutes is going to be later uploaded. There's a bit of noise at my place, that's why I'm taking this break. So I will be, along with this, I will also be uploading the part 2 of this particular video.